So the question is saying a disk and a solid sphere of same radius are rotated as shown in the figure, and mass of the disk is 4 and the mass of this one is given. So then you have to find I disk and upon I solid sphere. Okay. So first we have to understand, you have to use two basic theorems. Okay. The parallel axis theorem and the perpendicular axis theorem. Okay. So first we'll try to find out for the disk. Okay. This is the disk. So if this be the disk, so I know that for a disk, the moment of inertia of this disk, about an axis passing through the center. So that is, into the page and out of the page. So I am denoting that axis by cross. Okay. So that axis, about that axis, the moment of inertia of this disk is mr square upon 2. This you must be knowing, right? Fine. And disk is a laminar body. Okay. This is a laminar body. So for laminar bodies, we apply perpendicular axis theorem. Okay. So if we try to find out the moment of inertia of the disk about this axis, okay, this is in the plane of the disk. Okay. In the plane of these two axes are in the, so let's say this is y axis, this is x axis. So this particular moment of inertia mr square by 2 is about the z axis. Okay. The black, the cross into the page and out of the page. Okay. But if I have to find out the moment of inertia about the axis x or the axis y, I'll be using the perpendicular axis theorem. Okay. And by symmetry, you must be seeing that the moment of inertia about the axis x has to be the same as the about the axis y, right? And the perpendicular axis theorem says that Iz is equal to Ix plus Iy. For laminar bodies, we apply the perpendicular axis theorem. Okay. So by that, I can say that if I have to find about the y, so Iy, I can say that means Ix is the same as Iy. So 2Iy is Iz. So that means Iy is Iz upon 2, half of that. Iz is this much, mr square by 2. Okay. So that means Iy is going to be mr square upon 4, right? So that means about this axis, the moment of inertia, this axis is in the plane of the disk, is mr square by 4. So if I have to find the moment of inertia about this axis, parallel to that y axis, but like this, okay, tangent to that disk. So then I'll be using the parallel axis theorem. Okay. This will be the radius r of the disk. Okay. So about this green axis, using the parallel axis theorem, the moment of inertia becomes 1 about mr square by 4 was about the center of mass plus mr square using the parallel axis theorem. Okay. Fine. So this was about the center of mass, through the center of mass, and then m times r square, where r is the distance between the two axes. Okay, you must be aware about the two theorems that we are using here. Okay, fine. So this is ultimately 5mr square upon 4, where m is the mass of the disk, right? md, let's write here. Okay. So for this one, it is 5 times mdr square upon 4, right? For the disk about this axis here. Okay. And for the sphere is 3D. So we can't be applying, any such perpendicular axis theorem, but we can apply parallel axis theorem. So about the center of mass of the sphere, the moment of inertia is 2 by 5 mr square, the mass of the sphere. And then about this axis, if I have to find, I'll again use the parallel axis theorem and add mr square to that. So this is going to be ultimately 7 by 5 mr square, where ms is the mass of the sphere, md is the mass of the disk here. So we have to find the ratio. Okay. Okay. So we have to find the ratio of, this is the I of the disk, and this is the I of the solid sphere. So if I have to find the ratio ID upon IS, that is going to be, they have the same radius. Okay. So R will cancel out. So I'm writing ID is going to be 5d md r square by 4 upon 7 upon 5 ms r square, right? So this is going to be ultimately 5 md by 4 into 5 upon 7, right? ms here. Okay. Now md ms, the mass of the disk is 4 and the mass of the sphere is 5, right? So m times md is 4, mass of the sphere is given to be 5, right? So now I'll try to cancel, this goes away, this goes away. So I am left with 5 upon 7 as the final answer. Okay. So this becomes my final answer, 5 upon 7, the ratio of the two moment of inertia, that of the disk upon that of the solid sphere about the given axis. Okay. That was tangential to both of them. Okay. Thank you.